Hi, so we're going to test for polar equation symmetry today. So first off, this is our first graph that we are testing. So we have r is equal to 3 plus 2 cosine theta, and we want to see if the graph is symmetrical around the pole, so from equidistant from the pole, so if like a point out here and a point out here are the same distance away from the middle, or if the graph is symmetrical about the line y, it's about the y-axis on a coordinate plane, but in a polar graph, it would be about the line y is equal to, or r is equal to pi over 2. Okay, so the vertical axis. And the horizontal axis would be the polar axis. Okay, so here we go. We have our first equation, and to test if the graph is symmetrical about the polar axis, we're going to take r and theta, and we're going to replace it with r comma negative theta, or if that doesn't work, then we're going to replace it with negative r comma pi minus theta and see if that works. So what we'll do is we will take our original graph, our original equation, and replace r with, we're going to start with this first point. Okay, so we'll leave r and replace the second part with 3 plus 2 times the cosine of negative theta. Because cosine is an even function, we know that the cosine of 3 plus 2 cosine negative theta is the same as 3 plus 2 cosine of regular theta. So we can see that what we ended up with is that these two equations are equal. So the equation r, so we'll just say that it's symmetrical with respect to the polar axis, which would be this axis right here. Okay. All right, the next one we're going to do is looking to see if our graph is symmetrical with respect to pi over 2, which is the vertical axis right here. And so this is one example. Okay, this is one example of a graph that is symmetrical about the line pi over 2. So what we're going to do is replace r and theta with negative r and negative theta. And if that doesn't work, then we're going to replace it with r and pi minus theta. So I get r is equal to 1. Oops, sorry. We're replacing r with negative r. So negative r is equal to 1 minus the sine of, instead of theta, we put in negative theta. All right, so even and odd function identities tell me that the sine of positive theta would pull out an extra negative, so this would be negative sine theta, so that's going to change this into a plus, and then we'll divide both sides by 1. So we get r is equal to negative 1 minus the sine of theta. These are not the same. Okay, so not equivalent. So we may or may not have symmetry with respect to pi to theta is equal to pi over 2. Okay, so the problem with these is that when your test doesn't work, it's inconclusive. We don't know if we're symmetrical or not. So there's another test to see if we have symmetry about the line theta is equal to pi over 2. It's right here. We're going to plug in the point r comma pi minus theta, and this is basically plugging in supplemental angles. So let's try this again. So instead, this time we're going to start over. We're going to start with r is going to stay r, and I'm going to replace the 1 with a 1 minus the sine of pi minus theta, okay? So we need to use sum and difference. So I have r is equal to 1 minus the sine of angle A, which is pi, times the sine, times the cosine of angle B, which is theta. I better pop this in parentheses here, like this, minus the sine of angle B times the cosine of angle A. Okay. Sine at pi would be 0, so that would turn us into a 0. And the cosine of pi is -1. So I can write r is equal to 1 minus, see, this term cancels, and then a negative times a negative will give me a positive. So I have 0 plus the sine of theta. Okay, this is going to equal 1 minus sine theta, which, what do you know? Our original and when we replaced r comma pi minus theta, we end up with the same equation. So we know that the equation r is equal to 1 minus sine theta is symmetrical with respect to theta is equal to pi over 2. Okay, so when they're equivalent, we can definitely say that the two that there's symmetry, but when the two equations are not equivalent, then it's inconclusive. Okay. Let's do this one. There's one more type of symmetry. It's when we have symmetry with respect to the pole. So it means that, like in this graph, this point and this point are equidistant from the pole, same as this point and this point. So the points across from each other are equidistant from the pole. Okay. So there's two different ways to test this. You can add these to your notes. The first one is to change r and theta to -r and positive theta. So let's go ahead and actually let's do the second one first. We're going to change r comma theta to r comma pi plus theta. So here we go. I'll replace my r with an r, and we're going to do cosine of 2 times pi plus theta. Okay, I'm going to distribute this 2. So I get the cosine of 2 pi plus 2 theta. Looks like I have a sum and difference. So I'm going to do the cosine of angle A, which is 2 pi, times the cosine of angle B, 2 theta, minus the sine of angle A, which is 2 pi, and the sine of angle B, 2 theta. Okay. So at angle 2 pi, we have a cosine ratio that is a +1. And at sine of 2 pi, my ratio is 0. So we have r is equal to the cosine of 2 theta plus minus 0, so the cosine of 2 theta. So I can see with this test that I have symmetry with respect to the pole. To the pole. Okay, if we had done the other test, let's try the first one, this one. We're going to change r to r, and then the cosine, okay, here's my original. R is equal to 2 cosine 2 theta. We're going to replace r with -r is equal to the cosine of 2 theta. Divide by -1 to get r by itself. So you get r is equal to negative cosine of 2 theta. Well, these are not the same. So the test is inconclusive. We don't know if we have symmetry or not. So if we had started with that test, we would have had an inconclusive result, and then I would have tried this test instead, replacing r with r and theta with pi plus theta. Okay, so let's do one more. This time we want to know if r squared is equal to 4 sine theta. So let's go ahead and start with, I'm going to start with, let's start with the first one, okay? So let's see if our graph is symmetrical with respect to the polar axis first. So I'm going to start by replacing r theta with r negative theta. So polar axis. So we're going to replace r comma theta with r comma negative theta. Okay. So I have r squared is equal to 4 times the sine of negative theta. Even and odd properties tell me that r squared is equal to negative 4 sine of theta. And these not equivalent. So inconclusive. We don't know if that works or not. Okay, so then we're going to try r theta, and we're going to replace that with negative r comma pi minus theta. So negative r squared is equal to 4 times the sine of pi minus theta. This has r squared is just negative r squared is the same as r squared. And then we're multiplying 4 times the sine of pi times the cosine of theta minus the sine of theta times the cosine of pi. All right, so here we are at angle pi. Cosine is -1, and the sine is 0. So I have r squared is equal to 4. This term is going to cancel out, and I get positive sine of theta. So about the polar axis, we actually, since the two equations, the original and the new equation are equal, we have symmetry with respect to the polar axis. Well, as it turns out, there's more. Okay, so let's go ahead and try with respect to pi over 2. Okay, so I'm going to start with my original r comma theta, and I'm going to change that into r comma pi minus theta. Okay, see if this works. So my r is replaced with r, so r squared is equal to 4 times the sine of, oops, forgot some letters, of pi minus theta. Sum and difference formulas. 4 times the sine of pi times the cosine of theta minus the sine of theta times the cosine of pi. This is similar to what we had before. Okay, sine of pi is 0, and cosine of pi is -1. So these cancel, and I get r squared is equal to 4 times, we have a negative times a negative, gives us sine of theta. So really we had the same as we had before, just I didn't have a negative r squared to square, so, or negative r to square, so I end up with a positive r squared still. So my original and my transformed equation are the same. So we also have symmetry about theta is equal to pi over 2. All right, lastly, let us go ahead and check our symmetry about the pole. Okay, so I'm going to check, I think the fastest one for us is if we're going to check negative r, comma, theta. Oh, sorry. We're going to start with r theta, and we're replacing it with negative r, comma, theta. Okay, so I have r squared, which we're replacing with negative r. So negative r squared is equal to 4 times the sine, and theta is just being left as theta. So negative r squared is just r squared, which is equal to 4 times the sine of theta. Hey, what do you know? This also works. So we have symmetry about the pole. Okay, so what does this graph look like? Well, let's see. I have this graph right here. So in Desmos, you do have to get r by itself. So I split, since we unsquared the r, I put two equations, this positive square root of 4 times sine of theta and negative square root 4 times sine theta. And this, so together the graph looks like this. You can see if I draw the line at the polar axis, we have like vertical symmetry, we have horizontal symmetry, okay? And then we also have symmetry about the polar axis. So, about the pole. So every 180 degrees or every pi units apart from each other, we have a point across the grid. Okay, and so these are the different ways that we test for symmetry in polar graphs, and we use the symmetry to kind of help us figure out like how many points we actually have to make to be able to graph the polar equation.